Bismillahirrahmanirrahim. Power system protection. So we have started the bus bar protection. So uh, now we have to discuss the different bus bar protection schemes. The first one is known as current differential protection scheme. Okay. So as I have told you earlier, in case of transformer and the generator, the main operating principle of differential protection scheme, that is the current entering and the current leaving to be protected, uh, are compared. The current entering and leaving to the device to be protected are compared. So in this case, the I1 and I2, these two are and I1 and I2 of the CT is secondary. These two currents will be compared. Okay. In case of the external fault, for example, this is the external fault somewhere here. Uh, in this condition, in this case, in this condition of the external fault, the two current are ideally zero, but practically it is not zero because of some reasons. So this current is ideally zero, and hence a relay is not going to operate. So whenever in case of the internal fault, this is for example the internal fault case. Okay. So okay, so whenever in case of the internal fault in the bus or the equipment, hence these two current I1 and I2, that is addition of that, hence I operating I1 plus I2. Okay, if these values exceed the pickup value of the relay, then the relay operates. Okay, so let us discuss first type of scheme in differential protection, that is circulating current differential protection scheme. Okay, this type of scheme we have already discussed in the generator and transformer protection. This scheme has only one coil, that is the operating coil. However, this type of scheme mal-operate because of two reasons. Number one reason is the length of the lead. We have already discussed this reason. So the length of the lead connected to the CTs to the relay, that is usually not equal. So burden of the CTs are unequal, and because of that, some value of the current will flow through the operating coil of the differential relay. This current is known as spill current. Okay. So during normal condition and in through fault condition, the differential current, of course, of very small magnitude, that always flows through the operating coil of the differential relay, and hence the application of the simple differential scheme protection scheme, that is not actually beneficial when we consider the bus bar protection. Okay, so you can see here, if I wish to apply the circulating current differential protection scheme for bus bar protection, this is your bus bar. Okay, this one the uppermost, this one your bus bar, and these three are the outgoing feeders. Okay, these three are the outgoing feeders. You can see that on each feeder I have one CT. Okay, CT1, CT2, CT3, one CT, and when whatever relay I use, that is the three relay, three phase relay, which has only one coil. Okay. However, the main requirement, okay. However, the main requirement of this scheme is that CT should have same ratio. If these conditions are not satisfied, then the differential relay mal-operate or spill current will flow. Even though the saturation, even though the saturation characteristic of all the CTs is identical, the differential relay may mal-operate because of the transient DC component. So practically, it is not possible even though the CTs are manufactured by the same manufacturer. Then also differential relay mal-operate because of the transient DC component that represent in the fault protection. Okay, so advantage of circulating current differential protection scheme, uh, that is a very simple scheme. This is the only advantage of this type of protection scheme. Okay, and there are many disadvantages. This type of scheme required dedicated cities for all the lines connected to the bus. Okay, and this type of scheme may mal-operate because of the CT saturation. We have already discussed the CT saturation in our earlier class. So the relay may mal-operate because of the CT saturation in case of heavy fault. Okay, CT ratio mismatch or if transient component or DC decaying component present in the fault. So how to avoid this? Okay, to avoid this, to rectify this problem, biased or percentage differential protection scheme is to be utilized. So in biased or percentage differential protection scheme, instead of operating coil, along with operating coil, you have the another coil that is known as restraining coil. Okay, we have discussed this in our transformer protection scheme as well. Okay, so this is the mechanism to avoid the mal-operation of the relay, and this is called bias differential protection scheme. Okay, in this bias differential protection scheme, along with operating coil, we need another coil that is known as the restraining coil. Okay, so operating coil, the current flowing through the operating coil is I1 minus I2. Okay, but in the current through the restraining coil is I1 plus I2 divided by 2. Okay, these are the absolute values. Okay, in both the operating coil and restraining coil. Okay, and in restraining coil we have the average of the current flowing through the restraining coil. So there are two types of setting available, as I explained in the case of generator and the transformer. The first setting, that is the pickup setting. Okay, the pickup setting or the sensitivity setting. Okay, so this setting is nothing but I1 minus I2. If this value I1 minus I2 absolute is uh, exceeds some threshold 1, then relay will operate. Along with with this logic of percentage bias, which is nothing but the I1 minus I2 divided by I1 plus I2 into 100. Okay, this is the percentage bias. I1 minus I1 plus I2 divided by 2 in case of percentage multiplied by the 100. Okay, so when these two values percentage bias greater than some threshold value, so when these two uh, values exceed, then the relay will operate. Okay, if I consider the characteristic of a biased differential relay, then on the x-axis I have the I bias, and on the y-axis I have I differential. Okay, the swinging current I plus I1 plus I2 divided by 2 on the x-axis. On this is the bias current I1 plus I2 divided by 2. On the y-axis I have the differential current, that is I1 minus I2. Okay, and if I draw with the two slope characteristic, then the first slope and the second slope. Okay, this is the first slope, this one is the first slope, and this is the second slope. Then you have any fault, then you have any point faults on the above this line, this is the operating region or the working region of the relay. And if any point falls below the this characteristic line, then that region is the non-operating or the restraining region. Okay. Now, the advantages of bias differential protection scheme includes number one, the high tolerance against the substantial CT saturation. It has a reduced requirement of dedicated CTs, and it can be used comparatively for high relaying. Okay, so however, the main disadvantage of this type of relaying scheme, that is the mal-operation of CT. In case of closing external fault, the CT mal operates. So to overcome this, the next type of scheme that is used as high impedance voltage differential scheme. Okay. The disadvantages: it may mal operate in case of close in external fault due to complete saturation of the CT. So to avoid this spill current due to CT saturation in case of the external fault, high impedance voltage differential protection scheme is used. Okay. The effect of saturation is controlled by keeping the CT's secondaries and lead resistance low, and by adding resistance to the relay circuit. This is the best suitable protection scheme. The effect of the CT saturation is controlled by CT secondary and lead resistance, and by adding resistance in the relay circuit. However, here a full bridge rectifying circuit adds, okay, adds with substantial resistance in the circuit. And if I have look, this is the bridge circuit. Okay, so if I have this point along with this L and C circuit, so the LC circuit is tuned for tuned to how much frequency? 50 hertz to respond only to the fundamental frequency component of the current. So this type of scheme makes the relay immune to DC offset and harmonics. So you can see it is a similar to you have the three outgoing feeder form the bus bar. Okay, this is the bus bar. Okay, and these three are the outgoing scheme we have already discussed in the first bus bar protection scheme, but this tune circuit is added. Now this tune circuit is added. Okay, the three CDs are connected as it was connected in the earlier circuit. Okay, so I have connected through some variable resistor, and in parallel with this I have connected the LC circuit. This is the LC tune circuit with the bridge rectifier circuit. Okay, LC tune circuit, bridge rectifier circuit, variable resistor, and over current relay. So this type of scheme that is capable to discriminate between internal fault and external fault through the relative magnitude of the voltage across differential junction point. So if I just take the advantages and this type of scheme that provides stability against the transient DC component that present in the part, and it has improved CT saturation. Okay, the improved CT saturation characteristics are because of the R state stability. However, whenever I use the stabilizing resistance in series, okay, in series with the relay coil, sensitivity of the relay reduces. So this is the main disadvantage of this type of scheme. Along with this type of scheme require dedicated CTs, so cost will be increased. And this type of relay also mal-operate when secondary leakage reactance is present. So, and this type of scheme is also not capable when the reconfiguration bus bar arrangement is possible. So that means if I want to change the bus bar arrangement, then retrofitting of the scheme is not possible. So for this purpose, we have the fourth type of protection scheme that is known as protection using linear couplers. So in this case, instead of utilizing conventional CT, you are going to use the air core CTs. So saturation in iron core CT, that is again completely rectifying by using the linear coupler, which is nothing but the iron core CTs. So these CTs are changed. Okay, these three CTs are CT1, CT2, CT3. These three are changed. So the output voltage across the linear coupler that is proportional to the derivative of the input current. Summation of this voltage across the relay is zero. Then the input current that is equal to the output current, so no fault on the bus. Whenever in case of internal fault, all the line current flowing through uh, all the current flow through towards the bus, and thus the induced voltage appear across the relay. That is significant, and it exceeds if it exceeds some value, then the relay will operate. The linear coupler is special device and it can be effectively used when CT saturation phenomena is predominant. However, this type of scheme requires additional equipment to realize the benefit of the digital relay. Okay, the digital relay. That that increases overall cost of the scheme. So the next type of scheme applicable to bus bar protection, that is known as directional bus protection scheme. So the basic principle in case of directional bus protection scheme is if the power flow in one or more circuit is away from the bus, then the external fault exists. Whereas if power flow in all the current into the bus towards the bus, then the internal bus fault exists. Okay. So in directional bus protection scheme, first type of scheme that is known as series trip directional scheme. So you can see here, this is the bus bar. Okay, and you have two outgoing lines. Whereas CB1, circuit breaker 1 and 2 are connected with the CT1 and CT2. CB1 is connected to the CT1, CB2 is connected to the CT2. So you have the relay 1 and the relay 2, both are connected. And in this direction relay, so the secondary of PT input that is also required to each relay. And if I just look at the control circuit of this relay, the contact of relay R1 and R2 are connected in series. That's why it is series strip directional scheme. So whenever these two contacts closes, the auxiliary relay energizes, which is going to trip its contact, that is AX1 and AX2. And finally, the trip coil of the circuit breaker will be energized. Okay, so this was the operating principle. Now, what are the main advantages? Okay, so the main advantages of the directional protection scheme is it is not affected by the CT saturation as it compares the direction of current and also the magnitude. However, there are certain disadvantages of the directional protection scheme. The first is the reliability of this type of scheme is compromised by too many series contacts. Its circuitry is complex. This is the second disadvantage. Careful and periodic assessment is required because it has the complex circuitry. And this type of scheme require more time to operate the coordination and which is going to initiate all series connected contacts of directional relay to clear the bus part. So time of operation of this type of scheme is more than one cycle. This is another disadvantage. So if it is not used in actual or practical field, so in practical field, the scheme or the relay use that is digital or numerical relay. This type of relay incorporates modeling of CT response to eliminate the errors because of the CT saturation. It uses several processing units which is going to collect the CT secondary current, the PT secondary voltage, status of this circuit breaker and isolator connected with the line, and Then finally it accumulates it to the central unit. Finally it communicates with the central unit. So with proper algorithm and logical judgments, the central unit distinguished between internal and external faults. The modern the modern digital bus bar protection scheme that is classified by two ways. Okay, the first type of scheme that is known as this decentralized bus bar protection scheme, and the second type is centralized bus bar protection scheme. Okay, so in both the schemes, whether we have the centralized bus bar protection scheme or we have the decentralized bus bar protection scheme, this unit, that is the central unit, that is always there. Whether you have the separate central unit for okay, whether you have the the separate uh, central unit for each line or feeder, or you use a common centralized unit. Okay, in this way the decentralized and centralized busbar protection schemes, that that is different. Let's see what is the decentralized busbar protection scheme. Okay, so you can see that this is the diagram of decentralized bus bar protection scheme, where you have the bus bar. This is the bus bar, and you have three outgoing feeders, one, two, and three. In each outgoing feeder, you have three circuit breakers along with three CTs, one, two, three, and you have a data acquisition unit connected across the secondary of the CT. So each city you have the data acquisition unit, which is going to acquire the data and is also going to give the signal to the circuit breaker. So that's why you can see data acquisition units. Okay, so you can see the arrow. So the arrow is giving with each is given with each data unit. It is going to acquire the signal, and this each data acquisition unit, that is controlled by the central unit. This is the central unit. Okay, so this type of unit also provide signal to the circuit breaker, as I have told you. And this type of scheme separates central unit for gathering all the processing. So transmission of the data between the central unit and data acquisition unit, that is usually performed by the optical fiber cable. Okay, now if I consider the decentralized bus bar protection scheme, then it requires the wiring. This is the reduced wiring. So this is the advantage, the main advantage of this type of protection scheme. However, this type of protection scheme is required the very complex circuitry, and at the same time the data transfer rate required for from central unit to the data acquisition unit, that is also sufficient. So for that, the scheme utilized, that is known as centralized protection scheme. So you can see, you can have the circuit diagram of the centralized protection scheme. Instead of separate data acquisition unit, which was data, which was in the case of the decentralized, you have the one centralized unit. In this, you can see separate data acquisition system were provided. So this was the case in decentralized, but in centralized, you can see that one centralized unit which is going to acquire the data from each city. You can see at the same time it is also going to send the signal to each circuit breaker. Okay, so this is the data gaining from the cities incoming towards this central unit, and the below line is outgoing signal to the circuit breaker. The upper line is signal feeding to the current value feeding to the central unit, and the below line is the decision of the central unit according to this input signal. So the signal output signal is feeding to the circuit breakers, to each circuit breakers. Okay. So in this scheme, it is mandatory to connect all the signal at one central location. Single relay performs all the calculation. All the pre-processing and computation, such as sampling, filtering, analog to digital conversion, digital to analog conversion, and the relay logic, that is all thing. So every calculation are performed in the central unit. Hence, this type of scheme imposes more computational burden on the central unit. So with this, we have discussed, we started our discussion. Okay, so uh, this was all about the centralized bus bar protection system. Okay, now let us revise the whole lecture. So we have started our discussion with the different types of bus bar protection scheme. We started with the different differential scheme. Then we have discussed the directional bus bar protection scheme, and then we have started the discussion of the digital scheme or the numerical bus bar protection scheme. And for each scheme, we have discussed the advantages and disadvantages of each scheme. Okay. Okay. In the next lecture, we will start. We will switch our discussion to the another switch gear protective device, that is the circuit breaker. Okay. And then in the circuit breaker, we will discuss the different types and the arcing mechanism. Okay. And after the circuit breaker, we will discuss the fuses. Okay. And the the comparison of the circuit breaker and the fuses as well. Okay, so that was all about the bus bar protection scheme. I hope you will understand the whole lecture. Okay, thank you.